That's really fun. Like, literally, I do the readings and everything, and I still get like the closest on the reading papers. I'm like, it's open out.
Oh no.
Yeah. My notes are like very detailed. I read it all, and then I'm like getting pluses, and I'm like, that's really bad.
Yeah. All right, guys, let's go through them. So the first one here, some Pythagorean identities for you. What is 1 minus sine squared equal to? Okay, so I've got cosine squared x. And then tangent squared, what could I rewrite that as? Sine squared over, okay, cosine squared. And then what happens? These are gone. And we're done. So sine squared equals sine squared.
Okay, if you just know that like tangent squared times cosine squared equals sine squared, can you just like put cosine plus?
No, rewrite tangent as sine squared over cosine squared. Yep. Tangent times cotangent, you can say that is just 1.
Oh,
That's okay, because those are just reciprocals of each other. Yep. Walking around, it looked like we did pretty well on number 1. Number 2 was a little trickier. Some of you got creative with your fractions. All right, I'm going to work on the right side. You could work on the left. You'll get there either way, but I'm going to do the right side, and I'm going to find a common denominator. What would the common denominator between these two fractions be? Right, and how'd you get that? By multiplying what?
If you can add minus 1 times this plus 1.
Yep, exactly. And you can write it just as the squared version right away. I'm just going to write it out so we see what's happening. Okay, and then I look at that first fraction. I have the sign in the numerator. What was that fraction missing from the denominator? Like which factor? Yeah, the plus 1, right? So I'm going to take this times cosecant of x plus 1. And instead of cosecant, what could I write cosecant as? And over here I've got sine times, what was that fraction needing? Yep, so I'm going to write 1 over sine minus 1. So guys, that's just finding a common denominator. Some of you left them as 2 separate fractions with same denominators and did your work that way. That's fine. It doesn't matter. Both ways work. Then I'm just going to distribute. So sine times 1 over sine is just 1. And then that'd be plus sine of x. Again, sine times 1 over sine is 1. And then minus sine of x over my lovely denominator here. And I'm going to go ahead and multiply it. So cosecant squared x minus 1. What's really left in my numerator now? 2. And Pythagorean identity, what is cosecant squared minus 1? Okay. You can absolutely go straight from that to 2 tangent squared. If you want, you can also show, okay, cotangent squared is 1 over tangent squared, which means this is 2 tangent squared. Okay. Questions? All right, we will keep doing proofs over and over and over. Next week on Monday, we'll just do extra practice on the proofs and the stuff we learned today. Okay, so we'll keep revisiting these guys. The more you do, the better they get. Any other questions before we jump into the notes? Oh, and someone had asked if I would open the second attempt on homework 4.1. That is now open for you guys too, okay? All right. right, so go ahead and get out whatever you're taking notes on. All right, guys, I want to know, is the sine of 30 degrees plus 60 degrees the same as the sine of 30 degrees plus the sine of 60 degrees? I'm going to vote for no.
Yes.
Yes. I'm just going to disagree.
No.
No. No.
Definitely not.
Okay, I appreciate the one vote for difference of opinion there. Initially, you're like, oh, I can distribute sine. That makes sense, right? No, that's not how sine works, okay? You are not just distributing. If you think about the left side, 30 plus 60 would be 90 degrees. What is the sine of 90 degrees? 1. Okay, on the right side over here, what is the sine of 30 degrees? Oh dear, guys, what is 1/2? Good job. What is the sine of 60 degrees? What do you think? Does 1 equal 1 plus root 3 all over 2? No. Okay, so it's close, yeah. We can't just like pick 2 random angles and add them together and think we can do the sine of each of those angles. It doesn't work that way. So we have what are called the sum and difference formulas. Because right now you guys could only evaluate things of like 30, 60, 45, right? We're going to be able to throw in a few more of those with these sum and difference formulas. Like you'll be able to do the cosine of 15 degrees, things like that. Okay. So lots of formulas for you today. Sum and difference formulas. All right, we'll start with sine. The sine of A plus B. A and B are just angles. It is equal to the sine of A times the cosine of B plus the cosine of A times the sine of B. Okay, it's the sum and difference formula, so we're also going to do the difference. So sine of A minus B. It's the exact same thing, but with a subtraction sign. So sine of A times cosine of B minus cosine of A times sine of B. All right, then we've got cosine. All right, if it's cosine of A plus B, that is cosine of A, cosine of B, minus sine of A, sine of B. Cosine of A minus B, it's the same thing, but with the opposite sign. So cosine A times cosine B plus sine of A times sine of B. So the sine formulas follow the sign you're dealing with, adding or subtracting. Cosine will be opposite. And we just have tangent left. So tangent of A plus B. Tangent of A plus tangent of B all over 1 minus, got my A, tangent of A times tangent of B. Put that up a little for you. Then tangent of A minus B, same thing, but opposite signs. So you'll have tangent of A minus tangent of B all over 1 plus tangent of A times tangent of B. All right, so that's all the formulas for today. So we don't have like a secant, a cosecant, and a cotangent formula. How do you think we might do one of those problems? Like if it's a cosecant problem, what am I going to do? Yep, so if it's cosecant, you'd go through the whole problem as if it's a sine, and then at the end you would do the reciprocal of your answer. Okay? All right, so let's try some. Okay, so we're going to be evaluating. Great, and we'll start with the cosine of 15 degrees. Okay, so based on angles that you know from the unit circle, can you think of 2 angles? What did you say?
45 minus 30.
45 minus 30, good. There are lots of other angles you could have picked. You could pick 60 minus 45. You could pick 315 minus 300 if you wanted to. Staying in the first quadrant makes it easier because you don't have to worry about any negatives. So let's do 45 minus 30. Okay, so what I'm going to do is write this out using the formula. So the 45 and the 30, that's your A and B from the formulas up above. So it's going to be cosine of 45 degrees times cosine of 30 degrees plus sine of 45 degrees times sine of 30 degrees. Does that make sense? We're just plugging it into the formula. Okay. All right, then we have to evaluate. What is the cosine of 45 degrees? This is all from your unit circle, guys.
Wouldn't it be minus root 2?
No, so the cosine formulas.
Oh, it's cosine.
Yeah, when it's cosine, the signs don't match, so. All right, so what's cosine 45? Okay, good. So that'll be times the cosine of 30, which is, try again. Okay. Plus, what is the sine of 45 degrees? Nice. And the sine of 30? 1/2. Okay. All right, guys, what's root 2 times root 3? Root 6. Good. So I've got root 6 over 4 plus root 2 over 4. So can I add square root of 6 and square root of 2? No, you cannot. You cannot combine those. So it's root 6 plus root 2 all over 4, and that is your final answer. Okay? All right, guys, questions on that one? Do you see the process? Like you're picking angles, plugging them into the formula, evaluating. That's all we're doing, okay? And again, now if this had been a secant problem, you would flip that, and then you'd have to rationalize. Okay, fun. It's super fun, yes. All right, let's try again. Let's do a sine problem, and let's go back to radians. Let's do sine of 7 pi over 12. Okay, let's think on our circle. I'm just going to make a little tiny circle over here. None of the angles on our triangle are labeled as over 12s, right? But I've got, this is pi over 6, this one's pi over 4, and this one's pi over 3. I could even keep going, this one's pi over 2. Could I write all of those over 12? Yeah, what would pi over 6 be? Okay, 2 pi over 12. What about pi over 4? Okay, 3 pi over 12. What about pi over 3? Okay, do you see where I'm going with this? You don't have to write it out every time, but be able to visualize like, oh, I can find that common denominator and add them together. So what two angles do I want to add together here? I would simplify it back just so it's easier. Yeah. It does not. Nope. With the subtraction one, yes. But with addition, it does not. So we're going to say pi over 3 plus pi over 4. We okay with that? All right. Then we're using the formula. So it's going to be sine of pi over 3 times what? Cosine of pi over 4. Plus or minus? Which one? Good. What? Cosine pi over 3 times sine of pi over 4. Now, guys, even within that, if you had written, sine of pi over 4 times cosine of pi over 3, it doesn't matter. It's multiplication. 2 times 3, 3 times 3, doesn't matter. I would just be consistent for yourself so that it's easier to remember the formulas. All right, what is the sine of pi over 3? Good, 3 over 2. Cosine of pi over 4. Nice. Plus cosine pi over 3. 1/2, good. And sine of pi over 4. All right, did we notice anything? It's the same answer as the last one. Yeah, we get root 6 plus root 2 all over 4.
That's way.
Okay. No, they won't all be that exact answer, but they will be some version with a root 6 and a root 2 and an over 4. Okay? Depending on the quadrant you are in, you may have a negative root 6 plus root 2 or a negative root 6 minus root 2. Okay? But if you answer one of these and you get like square root of 5 plus square root of 7, like, go try again. Okay? Something has not gone well for you and you should try again. All right? Questions on that one?
So because the two things being added are in the first quadrant, nothing negative?
Correct. And think about it. It's the sine of something in the second quadrant.
So it's
Yep. And, you know, if you visualize where these are, 15 degrees is 15 degrees into this first quadrant. 7 pi over 12 is 15 degrees there. Does it make sense to you that a cosine of 1 close to the x-axis is going to be the same as a sine? Yeah. You can think through all of that. You can think through like, oh, well, if I was in the third quadrant with that, what would I need? Which one would be negative? That sort of thing. So hopefully the answers make sense. All right, let's try a tangent one. Let's do tangent of 105 degrees. Okay, tip for you with tangents. When you're doing tangent problems, guys, avoid the 30 degrees or the pi over 6s. What is the tangent of 30 degrees or the tangent of pi over 6? No. Remember when I made you that little...
square root 3 over 2.
Not quite. Remember when we did this and I said tangent of any of the over 6s is always root 3 over 3. The over 4s is 1. The over 3s is root 3. Which is going to be easier to work with in the problem? The root 3 over 3 or just root 3? Just root 3. So avoid this guy when possible. Okay? All right. So back to our problem. So what angles do you want to add or subtract to get 105 degrees?
45.
I like it. 45 and 60. Okay, so that's going to be tangent of 45 plus tangent of 60 over 1 minus the tangent of 45 times the tangent of 60. Okay, tangent of 45 is 1 plus tangent of 60. Root 3, good. Over 1 minus, what am I going to have in that denominator? Yeah. You can put 1 times root 3 if you want to. I'm just going to write root 3. Okay, we're not quite done. What do you think we have to do from here? Yep, rationalize the denominator. Anybody remember what it's called, what we have to multiply by? The what? It does start with a C. The conjugate. There we go.
I said it.
Okay, next. It might. All right, so what is the conjugate here? Yeah, 1 plus root 3. So I have to take numerator and denominator times 1 plus root 3. That is your well-chosen one. You're just multiplying it out. So 1 times 1 is 1. Then I'd have plus root 3 plus root 3. I know you could do that in your head. And root 3 times root 3 is just 3. In the denominator, all I have is 1 minus 3. So I've got 4 plus 2 root 3 all over negative 2. Yeah, so what am I left with?
Negative 2 plus square root
close. Minus root 3, because you're dividing both of them by a -2. So it's -2 minus root 3.
So it's the root 16 by root 2 over 4. Is that only for sine and cosine?
It is, yeah. So the root 2, root 6, all over 4, that's sine and cosine. All of your tangents will be some sort of 2 and a root 3. -2, +2, positive root 3, negative root 3, okay? This one, tangent of 105 degrees, 105 is in the second quadrant. Tangent is negative in the second quadrant, so I like it that I got a negative answer. That makes sense. Okay. All right. A few more to go. Okay, this one's going to look a little different. We've got the sine of 80 degrees, times the cosine of 20 degrees, minus the cosine of 80 degrees times the sine of 20 degrees. Okay, we're kind of working backwards on this one. So do you guys recognize one of the formulas here? It's the sine formula, good. Okay, sine of 80 minus 20, which is 60. Okay. We like those, don't we? We're just working backwards there, okay?
Why did you do the sine of 80 minus 20? Because it's the formula.
Do you see it?
Yeah.
Yeah, once you see it, it's like, oh, exactly. Yeah, when it's a sine, cosine, cosine, sine, you're like, okay, that's a sine formula. Subtraction means I subtract the A and the B. 80's A, 20's B. We okay with that? Okay. All right. We get to do proofs with these formulas as well. It's okay. They kind of lead you through the formula, or through the proof, because you have a formula. Now I am going to switch to some Greek letters here, so don't get scared. Cosine of alpha minus beta over sine of alpha times sine of beta equals the cotangent of alpha times the cotangent of beta plus 1. It's just like A's and B's, guys, but it's alpha and beta. Oh, is that what you're Sure? Okay.
Are we writing this A and B?
I want to make sure you're familiar with the Greek letters so that you don't get to a math-based question and go, what are they asking me? So they're not that bad. We don't use that many. We use alpha, beta, and theta. Those are really the only 3 that we'll use in the proofs, okay? All right. What side do we want to start on? Any thoughts? I would go left, because do you see that numerator, how that could be one of our formulas? Okay, so we're just going to expand that numerator on the left with the formula. So cosine of alpha minus beta, what is that going to become?
The whole
The whole thing. Okay, yes, correct.
thing.
The whole big thing. So cosine alpha, cosine beta, plus sine alpha, sine beta. My wall over here. Over, can't forget our denominator, sine alpha, sine beta. Yeah, like it helps you. It's like, hey, here's step one. You know a formula. All right, now don't go nuts crossing things out just yet, okay? Ease up on your crossing out. I know you get very happy to cross things out. Not yet. What do you think we need to do before we can cross out a bunch of stuff?
Simplify.
It's a good guess. I like it. Yes, we're going to write this as two fractions. We're going to like undo the common denominator. So that denominator goes in both fractions. So it's cosine alpha, cosine beta over sine alpha, sine beta plus sine alpha, sine beta over sine alpha, sine beta. Yes. You've got cosine over sine with alphas. You have cosine over sine with betas. So you can have a cotangent of an alpha, a cotangent of a beta, and then plus, what does that other fraction turn into? 1. And you're done. All right, so do you see what I mean, that the formulas kind of help you through the proof, at least on one step? It just started? Okay. All right, let's do another one. Another proof. Okay, so this time we have the sine of 5 pi minus x equals sine of x. All right, which side are we working on? Left. Do we have a formula to help us?
Yeah.
Yeah, what's it going to be? The whole thing. All right, so it'll be sine of 5 pi cosine of x minus cosine of 5 pi sine of x. Okay, on your unit circle, you're going around. It's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, okay? What is the sine of 5 pi?
0.
Good. So I've got 0 times the cosine of x minus, what is the cosine of 5 pi?
Oh,
Negative 1. So 0 times cosine,
0.
gone, right? Nothing. And then minus negative 1 would make that positive sine. And we're done. Okay? It's magic, yeah. It's like a weird combo of the proof, your formulas, evaluating, all of that together, okay? All right, let's do another one. This is actually our last example. Okay, this one's not a proof, even though it's going to look like, it looks like a geometry proof. I mean, you're going to have some given information, okay? But it's not a geometry proof, I promise. You are given that the sine of alpha is equal to 3 over 5. And that 0 is less than alpha is less than pi over 2. You are also given that the cosine of beta is equal to 5 over 13. And again, 0 is less than beta is less than pi over 2. I will tell you what all of that means. Okay, let's look at the alpha part first. You're told sine of alpha is 3/5 and that alpha is between 0 and pi over 2. What quadrant am I talking about if I'm saying between 0 and pi over 2? Quadrant 1. We have to draw a triangle in quadrant 1 where the sine of alpha is equal to 3/5. So I'm going to draw a little right triangle in here, just like we did last unit. Right angles on the x-axis. Alpha is the angle we're talking about, so I'm going to put that by the origin. And then it says the sine of alpha is 3/5. What does that mean? And the hypotenuse is 5. Yeah, so opposite or the y is 3 and the hypotenuse is 5. And do you know the other side of your triangle? Okay. Is a Pythagorean triple. All right, and then we have to draw another triangle for cosine of beta because beta is a completely different angle. It so happens that it is also in the first quadrant, so I'm going to draw another first quadrant triangle. Obviously, my triangles are not drawn to scale. They never are. Ooh, there's beta. Doesn't look like a beta. Okay, so cosine of beta is 5/13. What does that mean? Hypotenuse is 13. Good start. The adjacent or the x is 5. Yes. And what's the other? 12. Good. Okay. All right, let me write the rest of the problem now that we've established that. You have to find the sine of alpha plus beta. Okay, so formula for sine of something plus something. It's going to be sine of alpha times cosine of beta plus cosine of alpha times sine of beta. Now, where do you think I'm going to find all of these sines and cosines of alpha and beta? The triangles. That's why we had to draw them first. Okay, so what is the sine of alpha? 3 over 5. Cosine of beta. Good. Plus cosine of alpha. Good. Sine of beta. You could do some reducing in that first, little multiplication problem, but I'm not going to because I want to keep the common denominator so I can add these together. So 3 times 5 is over, what's 5 times 13? 65. 65, good. Plus 4 times 12, 48 over 65. You should always end up with common denominators when you're doing this. If not, go look again. Something went wrong, okay? Then we're just adding. So what's 15 plus 48? So your answer is 63 over 65. questions? Okay, guys. That was what?
That was a lot.
I know, it feels like we did that very quickly, but you made it through. So good work. We still have about half an hour left. So still debating on if I want to make you try the practice time 3 quiz. I think I want to just give you time to work on your math space. The second attempt is up, and I will pass back your Unit 3 test. Okay? Sound good? So maybe you can like get the homework done before break.
Yes. Like, is we do like count, or are we gonna do a practice one?
No, we'll do a practice one. So.